Navigating large datasets can be a tedious task in everything from getting an overview to locating a specific entry. In the field of visual analytics, one approach is to provide visual guidance by, for example, pointing users in the direction of a stored data item. But adding more visual elements to guide the user also adds to an already complex and potentially cluttered visualization. Wouldn't it be better to instead use a different channel, like haptics, to do so? Existing research on multimodal interaction shows that this could actually lead to performance improvements from visual offloading and greater accessibility across situations and users. How can we provide haptic guidance? The answer is literally already at our fingertips: the computer mouse. We developed a 2 degrees of freedom force feedback mouse called Caster. Its feedback can be applied along 2 movement axes with high detail and a wide range of intensity. Through its feedback, we can exert a variety of effects, from simulating surface textures to mimicking the push and pull of springs. From a literature review and conceptualization, we selected 2 methods and a subset of parameters for further exploration of the idea of haptic guidance. These 2 methods are pulling, meaning to drag the mouse towards a specific target with varying degrees of strength, and constraining, meaning to confine the mouse within a bounding area with varying degrees of rigidity. Now, the question we set out to answer was, which of these 2 methods is more appropriate to provide guidance? Could it even be a combination of the 2? To answer this question, we implemented these 2 force feedback methods on top of a visualization of Wikipedia articles. Using this setup, we conducted a user study to examine the 2 methods of pulling and constraining for 3 different levels of force feedback. The study asked participants to locate a Wikipedia article in the visualization, aided by varying combinations of feedback. We recorded the participants' mouse movements and questionnaire responses, and we interviewed each participant after completing the study. From our study, we found changes in behavior and experience for both methods. Constraining feedback made participants stick closer to the direct path from start to finish. Pulling feedback, in comparison, made participants solve tasks faster, increasing the speed of their movements. Experientially, participants felt a decrease in sensations of physical and mental demand as the pulling force rose, while sensations of temporal demand increased. For both feedback methods, increasing the force gave participants greater confidence in reaching the target, but lowered their sense of being in control. This effect was strongest for pulling feedback. Together with the interviews, we can conclude that the 2 force feedback methods can provide guidance appropriately, as long as the feedback provided is not too intense to cause discomfort, and the user keeps the final say over the feedback. In sum, force feedback guidance shows great promise if used right, and is worthwhile to investigate in more depth in future research.